Hi friends, welcome back. So now we will see another project that is on statistics, right? So what we will have is there are some problem statement, and according to them we have to frame the project, or we can say we have to solve those problem, right? So that is nothing but simple project on statistics, right? All the concept are covered here, okay, with different scenarios. So let's get start. So again, we import the necessary library, that is numpy and panda, which we will be using in this project, right? So there is one data set that I have created manually, right? You can see that how I can made how I made this data frame, right? So here I have defined the data, okay, and these are the value inside. So I have given the column name here, right? So these are the column names, and you can see that what we have is we have plan to purchase. Basically these are product, right? So these are total number of product. These are the person, we can say, who plan to purchase product A, right? And these are the person who actually placed order for product A, right? And these are the person who actually placed order for product A, but they did not purchase that, right? So there is no, there is yes, and they plan to purchase, right? So these are the total values. So now the first question is, refer above table and find the joint probability of the people who planned to purchase and actually placed an order, right? So here we have one value, that is what it, so here what is asking that who planned to purchase and actually placed an order. So these are the plan to purchase and actually placed an order, right? So we have 400 people plan to purchase and actually placed an order, right? Out of how much? 2000. So 2000 are total people. So PO, that is nothing but the number of people who planned and actually placed an order. So these are 400, total is over 2000. So we will get that joint probability how? By dividing 400 divided by 2000, right? And we are rounding this value up to the 4 digit. So here you can see that the joint probability of the people who plan to purchase and actually placed an order, right? So this is the probability. So here you can see that how we formed that. Okay, so probability of A given B is written like this. I have also covered this in conceptual videos. Okay, so this is nothing but to get the probability A given B, right? So this is nothing but probability of A and B, right? And divided by probability of B, where the probability of A and B is nothing but our joint probability of both A and B, right? And probability of A, if we talk about this, that is the marginal probability of A, right? And where probability of B is nothing but marginal probability of B. Now next question we have is refer to the above table and find the joint probability of the people who plan to purchase and actually place an order, right? But here is a condition that is given, that people plan to purchase, they only plan to purchase but actually place that order, right? So here we will have two more things, right? That is let's say P1 is our probability of actually placed an order, given that a plan to purchase, right? Where P2 is plan to purchase and actually placed an order, where P3 is plan to purchase. So P3 are the person list who only plan to purchase. P2 is the person that plan to purchase and actually placed an order, whereas P1 is the joint probability, right? Where actually placed an order and they also plan to purchase. So this way we will get that probability of actually placed an order given that plan to purchase, right? So this is the probability that we will get. So 400 by 2000, that is nothing but this frame, all right? But here we have one more thing, 500 divided by 2000, that is nothing but our total who plan to purchase order, right? So these are 500 and out of 2000. So this way we will get that. Now the question is, an electrical manufacturing company conducts a quality check at specified periods on the products it manufactures, right? And historically the failure rate for the manufactured item is 5%. Okay, suppose a random sample of 10 manufactured items is selected. So now answer these questions. So the question is, probability that none of the item are defective. Okay, probability that exactly one of the item defective, two or fewer items are defective, and three or more items are defective. So here the main concept we need to know about the binomial distribution. So where it is widely used probability distribution for of a discrete random variable, right? So now first thing we have is the probability mass function. So this is talking about this. So we have some important function in binomial distribution that I have already discussed down, that is probability mass function. We call it as PMF. All right, second is cumulative density function, that is nothing but CDF, and third is plot the binomial density function. So that is nothing but to plot all those binomial distributions, right? Now let's start solving those questions. So again, to include our statistics, we importing scipy.stats, right? To plot all our visualizations, we are using matplot.pyplot. Here first we are giving our P and K. So as these are very essential part in PMF or CNF, in both the function they have been used, right? So here P is our 0.05. So that is nothing but the failure rate for item that company manufacture is 5%, right? So here in the question you can see that that is clearly given that the failure rate for manufactured item is 5%. So here is our 0.05, right? And our sample size we are giving 10, and that the range will be 0 to 11, right? That is n minus 1. Now to get that binomial, we are telling that okay, just call the probability mass function, right, and passing the value. So here what it will give is the binomial distribution. Okay, so if we get that binomial distribution, here you can see that this we are getting our binomial distribution. All right, second thing is probability that one of the item are defective. So that is what our very first question, right? And here we are getting the first, that is nothing but the zeroth value. So it is nothing but 0.598. All right, so here we are getting the very first values, right? So that is nothing but 0.59. Now next thing, it is saying that probability that exactly one of the items is defective. So obviously that is our this value, right? Exactly one of the item is defective, so that will be our 0.31. All right, so to answer the question, that is C question, two or fewer of the items are defective, right? So we need to calculate cumulative probability up to two items being defective. So as in conceptual videos, this thing already described that if that is like up to two, or we can say two or fewer, or two or more items are defective. So then we need to calculate cumulative probability. So here we will get that cumulative probability from the cumulative density function, right? So here we will get that probability that two or fewer of the items are defective is nothing but from this cumulative probabilities value, that is these, and for two or fewer, so the highest one is again our 2, so 0 1 2. So here we will get that this value. Now the next is that there are more of the items are defective, three or more, right? So if the question is or more, like more than this value, so we simply subtract that from 1, because 1 is our 100%, we can say, or the thing that we need to subtract, right? So here we will get that the three probability of three or more of the items are defective, right? Next thing, the next question is, a car salesman sells on an average of 3 cars per week, right? So again we have to frame these questions. What is probability that in a given week he'll sell some cars, right? What is probability that in a given week he'll sell 2 or more but less than 5 cars? Plot the Poisson distribution functions for cumulative probability of cars sold per week versus number of cars sold per week, right? So here the interesting thing we need to know is again the Poisson distribution, right? Again, the discrete distribution, which also plays a major role in quality control, right? So this is the description about the Poisson distribution, as the this is a discrete probability distribution, right, of counting of event that occur randomly in a given interval of time space. All right, so these are some properties that we have in Poisson distribution. You can get the note from here, right? And now to answer these questions, right, all these three questions. So again, that is telling that what is a car salesman sells on an average 3 cars per week, right? So rate is 3, which is our mean, that 3 cars per week, and we are getting n in the CDF n rate, right? So here we are plotting that plot. This is the notation we are providing. We are labeling some text for title, X label, Y label, and finally we plot that Poisson distribution. So here you can see it. So this was nothing but our question number 3rd, to plot the Poisson distribution function for cumulative probability of cars sold per week versus number of cars sold per week. So in this way you will have to frame the question, okay, or the problem statement. Now next question we have is the accuracy in understanding order for speech based bot, right, at a restaurant is more important for the company X, which has designed, all right, marketed and launched the product for contactless delivery due to COVID-19 pandemic. Recognition accuracy that measures the percentage of orders that are taken correctly is 86.8%. Suppose that you place an order with the bot and two friends of your independently place order with the same bot, right? So now we have to answer these questions. So before answering these questions, let's frame the problem statement, right? What is it? It is telling that because there are 3 orders and the probability of correct order is 0.86, right? That is nothing but 86.8%. All right. So again, to get that, we will use binomial distribution equation. All right. So putting all those value in that formula, we will get certain value from here, right? So for those value you can see that the probability that will 3 order are filled correctly. So this is what we get the mathematically, okay? So that is nothing but 65.4% that 3 orders are filled correctly, all right? And none of the order are filled correctly is nothing but 0.23%, and at least 2 of the 3 filled correctly is nothing but 95.24%. If we frame this programmatically, this is how we will get the values. Again, from math we are importing factorial, as this is we are getting from factorial values, and this is for the probability that all the 3 orders are filled correctly, right? So that is denoting x3. All right, x0 is denoting that none of the order are filled correctly, so this is the probability for that, and x2 denoting that at least 2 of the 3 orders are filled correctly. So here we will get that factorial. So f, that is factorial of 3 divided by factorial of 2, right, multiplied by factorial of 3 minus 2. So here exactly we get from here, from this problem statement. Now the question 5 stating that explain one real life industry scenario, right, other than the one mentioned above that we solve, and where you can use the concept learn in this module of applied statistics, right, to get a data driven business solution. So here we have some example for that. One is manufacturing industry, probability of finding out a faulty product out of a production batch, right? Customer service industry, probability of finding out number of customers to attend in a busy hour, right? Next thing is human resource, where we can normalize employee rating in an organization, and another is telecom industry, where probability of a phone call dropping in busy hours of the day, right? Now let's move forward to the part 2 of this project. So there we have given some context or the problem statements. What are these? So here is the context: company X manager, the main top professional basketball division of the American League system, right? So the data set contains information, all of that, and on all the teams that have participated in all the past tournament, right? So it has data about how many basket each team scored. So this is that another data we have given. Next thing is the times they came within the first two positions. So how many tournament they have qualified, so their best position in the past, all these data will be there, right? So we have the basketball CSB here, and the data set contain information all on all the teams so far participated in all the past tournaments, right? So basically the objective of this part of the project is that companies management want to invest on proposal on managing some of the best teams in the league, right? So the analytics department has been assigned with the task of creating a report on the performance shown by the teams, right? So if you will be responsible for that in the company, so you might given problems like that, right? So where you have given the data and you have to make a report on the performance shown on that particular data objective, right? So some of the older teams are already in contact with competitors, so hence company X wants to understand which team they can approach, which will be a deal win for them. So here by framing this question, I hope you most of you might have seen the movie that is let me show you. I think it is Moneyball. All right. Yeah, here we go. So this is the exactly same movie that we have the question here. So to know the statistics or analytics in depth, you can watch this movie once, right? So this was very popular movie in terms of data analytics. All right. So again, back to our questions. Here we have to do some predictions, or we can say the performance analysis, right? Now the question is, in terms of our project, read the data set, clean the data, and prepare final data set to be used for analysis. See, this is very important. Our data can be redundant, can be huge, or we just have to make this useful, right? We just need to extract the useful information from that data set. So whatever data is given to us, that doesn't mean that is accurate or proper data that we will do our final work on that. Before doing final work or final analysis on that data, we'll have to clean the data, right? Or to prepare that for the final analysis. So again, let's import some numeric operation libraries, that is NumPy, Pandas. All right, to access our OS operating systems module, we are again importing that. So basically this is nothing but sometime we need to access our cameras, some files, some musics, like that we import just OS. So here we have also used that. We'll definitely see where we have used this in this project. We are reading this basket data analysis, right? So this is the basketball.csv. I'll definitely provide it this in the description. You guys can also work with that, but that data will be for final use only, like for you, right? So this is the top 5 head of our data: team, tournament, score, played games, won games, right? Drawn games, lost games, like that. All the information regarding that baseball. Runner up, team launch, right? Highest position held. So from this we will have to start identifying the data, what the data actually refers to. All right, so if we get the tail, so here you can see that the tail is, again we are lots of data. Here you can see lots of missing data is also there. Now let's start the part of our data cleansing, right? So here what we are doing is we are replacing all these hyphen with zero to make it useful information, because these hyphen doesn't mean anything in this context. So we are just making that zero. Zero means nothing. Next thing, we are replacing the matching string. Okay, so what we are doing is we are telling that in the basket replace our two, right, value hyphen, and we are giving a regular expression, right? So same thing for underscore, we are telling that okay, just a value is a hyphen, right, and again regular expression true. So now similarly we have one tilde in our data, so we are telling that okay, we just replace that with this and regular expression again true. Now we are printing the updated data frame. All right, so this is what we replace the matching string, and this we get our fresh data. So now we displaying attribute of data types, right? So this is our basket.d type. So here you can see that by observing this we will get the data type. So you can see that lots of the attribution are of type object, right? Now it is telling that display attribute information. So again, to just call the info function, here you can see that now we have not we have no null values here, right, present in the data set, because we have already replaced them with useful information. Here you can see that we can also telling that okay, basket team launch as type int. So this type we can replace the type of data type of our data. So here what we did is our team launch, that is this is object here. So by just passing as type, it will convert that into integer, right? Here you guys test that, although I have ran it earlier, was working fine. Maybe some library was missing in my point. You can check them out and let me know if you find any problem, right? Right, so I have removed that output for now. So here you can see that now we are converting. So this is another type to convert object to int. What we are using is we are using the regular expression, right, and we are passing the temp launch value in that, and which are giving the basket temp launch value as type of int as final, right? So here for that we are creating a new data frame, that is basket new. All right, where it will have the value basket column not equals to team. All right, and finally we can display the data. Now the question 2 is perform detailed statistical analysis and EDA using univariate, bivariate and multivariate enforcement data analysis, EDA, and using all those techniques to get a data driven insight on recommending teams they can approach, which will be a deal win for them, right? Also, as a data and statistics expert, you have to develop a detailed performance report using this data. So this is also giving us hint that is we have to use statistical techniques and visualization technique to come up with useful metrics and reporting, right, to find out the best performing team, which are oldest team, which are highest team, like that, all the analysis that we required there. So again we are getting that age of each team, right, and we are taking that assumption the data is from year 2019. So we are telling that okay, in basket new there is one column that is age, and just get the 2019 minus basket of team launch. To team launch will be the value that we filtered above. So here this will return the age of them. Then creating new feature win rate. So how that will work, we are defining win rate, and we are telling that in basket new check the one games, right? So how many one games are there and divide them with played games. So this way we will get the win rate, right? How many one games are there and win rate, and we are returning that. Next thing, we are creating new feature and we are telling that the championship rate. Again we have a column in the data frame that is tournament champion, and we are dividing that with tournament. So this will we will get the champ rate. To make this thing in mind that how we will get this new rate. Okay, so we are just dividing that with total number of tournament. So now we are defining one new data frame, right, and taking the value, or we are filtering team age, win rate and champ rate, right, in the df1, and we are telling that sort all those value by age, and we need head 10, that is the youngest teams. How that? Because if this value will be sort, so that will be sort in ascending order. All right, And next thing we are telling that if we need to get in descending order, that means oldest age we need first. So what we do is we will sort value and we'll make it descending, right? So this will give the top 10 for oldest team. How if we need to get the top performing team, so we will sort the value with win rate, again ascending false. That means in descending order to get the top performing rate teams. If we get the low performing team, now make the ascending true, you will get the top low performing teams, right? If we want to get the top performing teams and top performing young teams, so this way to get again top performing team, make this ascending false, that will give in descending order. And to make it top performing young team, so just make it it's ascending true based on the age. All right. Similarly, if we want to get the top performing team, but top performing old teams, so again we will get this from ascending false, and we will get the age in descending false. Sorry, in ascending false. Now, if we need to plot the feature, so here you can plot this by using plotly. I'm getting the express, that is to make it more visualized, right? So if that is fig.px is scatter, we are taking the value that from basket new, telling that in x-axis we need team, y-axis we need win rate, color is divided based on teams, so you can check them out. Next thing, it is telling that plotting new features. So again, to plot all those new feature that we have, again we are getting that basket, team, win rate, and now we are telling that color should be filled according to age. Now we need to know that young versus old teams performance. All right, so here you can see that if we get the scatter, basket new, win rate, we are giving an x-axis. For y-axis we are giving highest positions held, right? Size is age, color, team, we have already given that, and we are finally showing that. But it is telling that if it is young versus old teams performance, right? So again that we are giving the same thing, but we are telling this time take size as per the age. All right, so these were some observation that we got when we were doing this project. So here you can see that young and old teams with similar performance. Team 6, so this is the win rate, highest position, age. So that is the team 21, which is win rate. So these are top two, right? Old team. If we talk about top two young team, that is team 57 and team 56, these are their respective values. So there are many columns available with many combinations. All right. Now, what if we want to mix the match column and comment the statistical distribution with them? So first we will get the match column, right? We are telling that get from basket new, y should be our age, and this time we are plotting that. So if we plot them in histogram, we will do like that. And if we plot as a pie chart, then we will do that like it. Observation, again the majority of the teams are from age 40 to 85, so this you will get from this plot. Now, next thing, it is telling that perform detailed statistical analysis on all possible columns. So again, first we are transposing our describe, right? So this is you can get it from describe function. Secondly, we are telling that match column and comment on statistical distribution based on histogram. So this time we are passing highest position held. All right, so this is basically histogram. To plot that in box plot, you can just use box here. All right, and if we have to get the correlation, so you will get the correlation from this basket new, right? Again, next thing, if we want to get the score and we are plotting that in box plot, so similarly you can just pass a score here to call that box plot. If we want to get that scatter plot, so again for x-axis we will give the played games, for y-axis we will give the won games. It will show the scatter plot for that, right? So here you can observe the same thing, that is a linear relationship will be found and exact correlation can be found using code. All right. Next thing, if we use a different column to plot that scatter plot, and now this time we are passing play games for x-axis, one games for y-axis, color is team. So on based on that, you can get that scatter plot. All right, and if same, you can also get that pie plot. See, all the concept are already covered in all the videos. This is nothing but a summary. We can say that where we are just recalling all those functions, how we have used them. So this is the pie plot that we are using in different values, right? Here again for scatter matrix, yeah, we are giving dimension for play games, one games, lost games, right? And again segregating that color with teams. All right, again to plot that scatter plot, we are passing different axes here, that is team for x, template for y. All right, so similarly, to get that histogram for each, you can just call this histogram, and that will give a plot for that histogram. To get that scatter plot, x for team, y for champ rate, that will return the scatter plot. So, what is the recommendation here is the company's management want to invest and proposal on managing some of the best team in the league, right? So, the analytics department has been assigned with the task of creating a report on the performance shown by the team. So, some of the older teams are already in contract with competitors. Hence company X wants to understand which teams they can approach, which will be deal win for them, right? So here that will the final recommendation that the company might ask. So the answer that we got are the common between below table 1 and table 2 should be recommend to approach. So what is the table 1? This is the table 1 that we are getting in df2. From df1 we are sorting values, and for this particular thing we just performing team we have is win rate, and we are telling that just get in descending order, right? And for top performing old team we are sorting that based on age. All right, and again in descending order for table 1. All right, now for table 2 we are telling that okay, just get the top performing teams for champ rate. All right, and top performing for sort them for top age. So first this will return the top performing teams. Now if we sort that, so it will return the ascending order of the top performing all teams. Now the question 3 is telling that please include any improvement or suggestion to the association management on quality, quantity, variety, velocity, veracity, etc. Or these are nothing but we can say the 5 dimension of big data, right? That is also a used concept. So data point collected by the association to perform a better data analysis in future, at least one suggestion for each point. So let's see, the above data analysis was focused around team age, winning rate, and a combination of 3 columns. Likewise there are 16 columns, right? So there could be hundreds of combination possible, and use your best analytics skills to perform data analysis to adhere to perform of the trim, right? There are many libraries which enable you to create effective graphs as well. So let's move forward to our part 3. That is nothing but we will again try to understand this theoretically. So as I have defined all the problem statement here, solution here, you can just type them and run them accordingly. So again we have the startup ecosystem, that is our domain for this part. Right, so here we have the company X is EU online publisher focusing on the startup industry, and the company specifically reports on the business related, that is to technology news, analysis of emerging trends, and profiling of new tech businesses and products. So their event, that is startup battlefield, is the world's, right? So that is startup battlefield is the world's preeminent startup competition. So startup battlefield features 15 to 30 top early stage startup pitching top judge in front of the vast live audience that present in the person and online. So here the data description is we have company EU CSV here, which row in the data set is a startup company and the column describe the company. So Project objective analysis the data of the various companies from the given data set and perform the tasks that are specified in the below, right? So here we will have this tab. Now first thing, we are reading the CSV. So let's first import the library that we will be using: NumPy, Pandas, Matplotlib, Seaborn. So this is the CSV that we have read, right? So this way you will get the CSV in the description as well. Now second question is data exploration. Check the data types of each attribute, right? So to check the data types, just call the d types. Check for null values in the attribution. Again, simply data.isNA.sum. So it will return all the null values respective to those columns, right? Turns out we do not have data of funds raised by all the companies. We would need it to perform the first task. Hence we will have to ignore the companies of which we do not have data for the funds they raised, right? So data pre-processing and visualization. So drop the null values, convert the funding features to numerical values, plot box plot for funds in million, right? So df1 data that drop NA, which is copy deep equals to true. So drop the row which have no data for frauds raised, right? df1 funding, we are dropping the values in this way. Now we are converting fund raise feature to a numerical values. So first we are getting as sample 5. All right, so here we are calling the fund in millions, okay, and telling that in funding dot apply, just apply lambda float for all those x, right, from 1 to last, and divide that by 1000. So again checking if x of that index is k, right? So then change this, else what do is just multiply that by 1000, right, if that is b. All right, and if nothing, then just write it as it is with float. So if we better explain this code, so within the lambda function we pass two else block, right? So if the last element in the value is k that we got here, then divide number of 1000. Else if it is multiplied, else if it is b, then multiplied by 1000 and return as it is. So we pass the lambda function to the apply method, which we use in funds raised, right? So column and assign the result of new column, that is fund in million in data frames. Now it is asking plot box plot for fund in millions. So simply we will call the plot dot box plot, right, passing the titles and y label. Then we are telling get the upper fence from the box plot. So to get that upper fence, we are telling that okay, in plot we have this caps, right, and we can use the value from box plot itself to get the upper fence. So just we are passing the value at 1 right, and getting the data. So to get the upper fence, we are calling the plot. All right, so in that plot we have caps at first position and we are getting data, right? So this way we will get the upper fence. Now to get that plot, we are telling figure size and access for subplots, right? This is the figure weight, right, and this is the figure width. This is the figure height and figure width we have passed. And finally, after providing that, okay, here what we are checking is if df1 dot operating system is operating funds in million, right? So just take it at 0 access, and if it is closed funds in million, take it as first access, right? So for access 0, right, so the funds raised by companies is still operating, so this will be the title. And for access 1, the funds raised by company that got closed. All right, so this way that will return the plot show. And if we check number of outlier greater than upper fence, so as we got the upper fence last time, so we are checking that just the number of outlier are if greater than this outer fence, so that will return the number of outliers. All right, now we are dropping the value that are greater than the upper fence. So just to call the drop. All right, in that df1 we are checking the condition, and if it matches, then just drop that, right, particular index and permanently. And finally, check frequency of the status features classes. So to get that, we just use the value counts, how many features are there, right? Now if we talk about the statistical analysis, so what we have is visually the distribution are quite similar. To prove if there is significant difference or not, we will have to perform a hypothesis testing. Since we want to compare the difference in means of sample, we can either use two sample t-test or z-test for that, right? So if we get that statistical analysis here, so here we have question: is there any significant difference between funds raised by companies that are still operating versus companies that got closed down? So what we will have to do is write the null hypothesis, write the alternative hypothesis, and test for significance and conclusion. So to get that null hypothesis, there is no difference between the two means. To get the alternative hypothesis, there is significant difference between the two means. Again, to get that from we are calling our z test inside the stat models, right? So here we have passed the operating and closed for sample 1, sample 2 respectively. Then we are giving the significance level, right? So that is in our case 5%, and we are telling that in test statistics and p-value, get the sample 1 sample value after performing the g-test, right? So here we are checking the condition. If the p-value is less than equals to alpha, so here it will say that okay, the difference is significance and we reject the null hypothesis in this case, right? And if that is not a condition, like p-value might be greater than alpha, then we can say that the difference is not significant and we fail to reject the null hypothesis. Similarly, if we perform t-test, right? So to get that, we are getting the t-test IND, right? And we are passing the sample 1, sample 2 for the same condition. If the p-value is less than equals to alpha, so we are rejecting the null hypothesis. And if the p-value is greater than alpha, so we are failing to reject the null hypothesis. As simple as that. So from the test above, we found no evidence to state that the companies that have raised more money tend to secure more or vice versa, right? Now what it is telling that make a copy of the original data. As simple as copy function will return the copy of that data, right? Here we are telling that frequency distribution of result variable, so it will return the result value here. All right. And next thing, calculate percentage of winners. So here to calculate the percentage of winners, again simply we are defining winners, right? Taking the value of those df2 dot result, and we are defining one contestants, right? From this particular column, and contestants operating, right? So we will get that if result equals to contestant, that value count, and for operating, and winners operating, again if that is not equals to contestant, then get that as operating. So winners operating divided by winners, and contestant operating divided by contents, right? So this will give that the accurate percentage for that. Now write your hypothesis comparing the proportion of companies that are operating between winners and contestants. So for null hypothesis, the proportion of companies that are operating is the same in both categories, that is for winner and contestant, that you will get after running this particular cell. Similarly, you will get the value for alternative hypothesis. And if we talk for test for significance and conclusion, so here you will again calling that proportion z test, right? So just passing the values that we just calculated above, contestant operating and contestant winner operating for test statistics, and for p values contestants and winners, right? So again, to check the null hypothesis and alternate hypothesis, you will check the same condition, whether you fail to reject the null hypothesis or you reject the null hypothesis. So finally, to conclude that the amount of fund in this particular section of the project that is a company raised is not a significant factor in deciding in the company will remain operational or close down, right? So winners in the battle have proven to remain operational more. So that means the companies that come out only of understand. All right. So the final thing, it asked me that select only the event that has disrupt keyword from 2013 onwards. So while I was finishing the project, so this particular question got in my mind. So to get that, simply we will use the lambda expression here for disrupt keywords only, right? So if you use the value count for that, that will definitely return all those events. All right. Okay, friends. Thanks a lot. Have a good time.